Thank you, Paul, and thanks to the organizers for inviting me to give this presentation. If you had come to my talk on Tuesday morning, you'll see that what I'll be presenting this morning is a subset of that and going into a lot more detail, which is the impact of aflatoxin regulations on global food trade. It has its motivation by a point that Ranajit had brought up just maybe about an hour ago and that we both mentioned on Tuesday, which is that a lot of the work over the last 15 years on the economics of aflatoxin regulations has focused around this one World Bank study that had accused the EU essentially of costing African countries attempting to export food to the EU $670 million every year. When I and other economists were interested in looking at that question a bit further, in fact, African nations were not attempting to export anywhere near that amount to the EU every year. In fact, a lot of the trade that they did outside of their own countries was simply with other African nations. And so then I got interested in answering the question, who is really trading food with whom, and what does this mean about the impacts of aflatoxin regulations and where the aflatoxin is winding up around the world? So I'll start with a very brief background on aflatoxin. Now you've heard 4 days worth of it, and then some information about regulations on aflatoxin worldwide. And then the large part of this talk is going to be on the tangled web of world food trade. The regulations on aflatoxin in food and their impact on global food trade, in which I'm going to be giving 2 case studies in maize and pistachios. The important thing to gather as far as aflatoxin in the context of world food trade is a point that both Anne and Ranajit have brought up earlier today, which is that aflatoxin is primarily a problem in warm climates. So it disproportionately affects the countries between 30 degrees north and 30 degrees south latitude. And it's primarily a problem from the human food exposure standpoint in maize, peanuts, and tree nuts, such as pistachios and almonds. The reason that many nations regulate aflatoxin is because we've known since the early 1960s that aflatoxin causes liver cancer in humans. Now, there have been a number of other adverse health effects associated with aflatoxin exposure, such as stunting in children and immunomodulation, acute aflatoxicosis, but by and large, these are not the bases by which governments make their regulations for aflatoxin. So what are some of these regulations? This slide has actually changed a little bit since Tuesday. I was informed by a new colleague from China yesterday that actually China has revised its aflatoxin standard in recent years from 40 parts per billion to 20 parts per billion. But as you can see from just a small snapshot of the over 100 countries that have set regulatory standards for aflatoxin in food, these standards vary all over the map. You have countries like Ghana in West Africa with no regulation for aflatoxin, maximum allowable aflatoxin in food. And then you have other parts of the world like the European Union that have set an allowable aflatoxin standard in maize of 4 micrograms aflatoxin per kilogram of maize. Now, what are the impacts of these differential aflatoxin standards on global food trade? We tried to answer this question by developing what are called social network models of trade. Now, a network model is a derivative of a particular area of mathematics called graph theory. It's simply a collection of nodes, dots, for example, joined in pairs by edges if there is some sort of relationship between the nodes. For example, all of us here in this room could represent nodes, and there could be an edge between us if we are friends or if we co-authored a paper together. You probably are familiar with the network model of a map in which there could be cities as nodes could be joined by edges such as roads if in fact there is a road connecting 2 cities. And we were interested in network models from the context of food trade. Network models recently made their debut in public health research when a number of studies came out of the Harvard School of Public Health showing that you were more likely to smoke if your friends were more likely to smoke, and your friends are more likely to smoke if you are smoking. And you are more likely to be obese if your friends are obese, and if you are obese, your friends are more likely to be obese as well. In essence, like attracts like, but the directionality is not that clear. We were interested in seeing whether there are any similar trends as far as world food trade. So in this food trade model, we wanted to answer the questions, do any trade clusters emerge? Because this has really important implications politically as well as far as trading partners and alliances and ties. Second, if there is drought or crop disease hitting one particular nation, or for example, if a nation decides to take a lot of maize and turn it into ethanol, which other nations are affected? And third, how do food safety regulations affect global trade patterns? So the way that we developed these global trade networks for maize and pistachios was as followed. We found trade data for maize and pistachios for all the different pairs of nations for 217 United Nations member states. For maize from 2000 to 2009 inclusive, every maize trading pair of nations, one nation exporting maize to another nation. And we found similar information for data for pistachio trade from the years 1996 to 2010 inclusive. For all of these years, we developed a global network model for trade, connecting individual pairs of nations if they traded maize and pistachios with each other. And then we determined the impact of aflatoxin regulations on these trade patterns. We relied on a variety of data sources, and we modeled this in a modeling software package called PIEC, which is the Slovenian word for spider web, because you get models that look like this. It does look a little bit like a spider web with a lot of insects caught in it. Now let me try to explain what this model shows. Each red node is representative of a nation that is either exporting or importing maize. And the size of the node is proportional to the square root of the amount of maize that is being exported out of that particular country. So as you can see, the United States on the far right is by far the largest exporter of maize around the world, and it forms the center of one cluster of trade where it is exporting maize to a lot of countries in North America, Central America, South America, and the Middle East. Clear on the other side, hardly engaging in any trade with the United States, are the European Union countries trading with each other, and the EU and the US are both trading with the countries in the middle, Brazil, Argentina, China, South Africa. So there seem to be three distinct trading clusters. Now, you might take a look at this and say, well, what kind of useful information could you glean from this? Among other things, a network model can reveal vulnerabilities in global maize trade. So what we like to call this type of topology that we see on the far right that's called a star-shaped topology. It looks a little bit like a radiating sun, and that's actually a very vulnerable part of the social network. That if anything were to compromise the supply of maize coming out of the United States, many other countries could be jeopardized in terms of their maize supply, because as you can see, many of them are not sourcing their maize from other countries. So they would have to develop new trade relationships, and that can be quite difficult to establish. In fact, this was a problem in the middle part of the last decade, in which we took a lot of our maize and we started producing a lot of ethanol from it. We really ramped this up between the years 2004 and 2007, and in 2007 there were riots in 22 different nations because of these increased food prices that resulted in large part from our maize ethanol production. And what we found in our paper that we published in 2013 was that 19 out of those 22 nations are nations that are kind of the surrounding in that star-shaped topology of the social network model of maize trade around the United States. Conversely, which countries in this network are less vulnerable? They're the nations that are well connected, they have lots of different connections, and they tend to be in the center of the maize trade network. Now, we were interested in looking at aflatoxin standards and how this has an impact on maize trade. So what we did in this map was to color code the nations based on the strictness of their aflatoxin standard for maize specifically. So you see that the European Union has, in the darkest red, has the strictest aflatoxin standard of 4 nanograms of aflatoxin per gram of maize. Then you see somewhat paler countries. You might look at some of these countries, for example, Australia and New Zealand, and say, well, really, there's no regulation on aflatoxin? They have a regulation on aflatoxin for nuts, but not for maize. Now, we wanted to take a look at overlaying the strictness of these aflatoxin standards on our maize trade networks, where now we normalized all the nodes so that they're the same size. We see roughly that, similar to the cases with smoking amongst peers, obesity amongst peers, here too, like tends to attract like. The countries with all the strict aflatoxin standards are all trading maize with each other. The countries with relaxed regulations or no regulations at all are all trading maize with each other. And this becomes even more apparent when you look at the top 20 maize trading pairs around the world. That with the exception of Argentina exporting maize to Spain and China exporting maize to Malaysia, these maize trading pairs have identical aflatoxin standards or near identical aflatoxin standards, not off by more than 5 parts per billion. So we found that to be interesting. And basically, network models of nations mimic network models of individual people. Now, we also wanted to see whether this was the case for pistachio trade, because we were interested in answering the question too, where is the aflatoxin then flowing around the world in food trade? It was a bit easier to try to answer this question as far as pistachios because there are only 2 countries really that dominate the global pistachio market. And those are Iran, exporting, they make up half of the global market of pistachios, and the United States making up a quarter of the global market of pistachios. For some countries, particularly in the Middle East, pistachios contribute up to 45% of dietary aflatoxin exposure. And there is a real difference in the level of aflatoxin in the pistachios coming out of Iran and the United States. According to a JECFA study in 2007 that measured samples both within the country and also being sent to the European Union. On average, there were 54 nanograms per gram coming from Iran and less than 15 nanograms per gram coming from the United States. So we were interested in answering the questions, which nations differentially import from Iran versus the United States, and do aflatoxin regulations play a role? We looked at, so what you see in this particular graphic are several things. The bars represent the times that the European Union rejected a consignment of pistachios coming either from Iran in the blue bars or from the United States in the orange bars. And so you can see that there have been a lot of rejections of pistachio consignments coming from Iran, and they peaked in roughly 2003 to 2005. They diminished somewhat afterwards, partly because Iran was not exporting as much pistachios to the European Union, and also in 2010, the EU actually changed its regulation on maximum allowable aflatoxin in pistachios. And then what you see in the green bar is the total amount of pistachios that Iran was exporting to the European Union, and the red line represents the amount of pistachios that the US was exporting to the European Union over the course of the years from 1996 to 2010. Now I'm going to show you some of these social network models from several particular years. Back in 1996, Iran was the major pistachio exporter to the European Union and worldwide. So here in our social network models, we put Iran and the United States in the center of the model, and the thickness of the arrow denotes the amount of trade to a particular region of the world. So it's trading a lot to the European Union. But then the next year, there were 2 pistachio consignments going from Iran to the European Union that had extraordinarily high levels of aflatoxin, up to 400 parts per billion. And after having received a second consignment from Iran that had such extremely high levels, the EU basically ordered a moratorium that year. They would not accept any more pistachios coming from Iran in 1997. So you can see there's not any really strong export to the EU in that particular year. Now, in 2003, what we see is that markets begin to shift. Now, suddenly, the United States is exporting a lot more pistachios to the European Union, and Iran is beginning to find new markets around the world, including, most prominently, the United Arab Emirates, which has a more relaxed aflatoxin standard. By 2009, most of the pistachios that the European Union is importing is from the United States, and Iran has largely found other markets. So it's not so much that there's this enormous direct economic loss every year from attempting to export to the European Union. Rather, these countries that are exporting their fruits are simply finding other markets. What it probably means, though, is that the aflatoxin is being concentrated in certain parts of the world and certainly not in the European Union. And we see this, that over the course of the last 20 years, there's been a really interesting market segregation, actually, where the U.S. is now we're exporting our pistachios to countries that tend to have very strict aflatoxin standards, whereas Iran is exporting its countries to the nations that tend to have more relaxed aflatoxin standards. And when we were preparing this work, we had published this 2 years ago in PLOS1, we had asked ourselves the question, but what about the issue of trade sanctions to Iran? Because that could have an impact even though there were no food-specific sanctions. And so we wanted a test case. How can we say for sure that that's because of aflatoxin rather than some other political reason? So we looked at the case of grape exports, where we were comparing export shares between Iran versus Greece. They both export a lot of grapes, but we didn't see that kind of evidence of market segregation, and aflatoxin by and large is not a problem in grapes. So we really think that this type of market segregation that we see is because of aflatoxin, as opposed to because of other political reasons. To summarize, when one nation sets a food safety standard, it doesn't just affect the people in that particular nation. There are ripple effects all over the world. Essentially, that's what happens when you disturb one part of the spider web of world food trade. The entire web is rippling. And aflatoxin regulations do appear to be associated with global food trade patterns. We don't want to say the word cause because we don't really know the direction of cause and effect. Is it that the nations were already trading food with each other so they deliberately harmonized their aflatoxin standards, or they had their aflatoxin standards and then they deliberately fashioned their trade in that manner? We tried to answer that question too when we found that there wasn't any consistent answer. Nations trade food, however, more with nations that have identical or similar aflatoxin regulatory standards. And the nations with a more relaxed standards or no aflatoxin standard at all are importing the food with a higher aflatoxin contamination. We see that these patterns exist irrespective of other potential political factors. So who is the most vulnerable as a result of these types of world food trade patterns? They're low-income nations that depend on food trade, either the exports or the imports, with either relaxed or non-existent aflatoxin standards. They're vulnerable because if anything happens to the main person who might be the main nation providing them with food, they would have to scramble to source food from other nations, and also because they may be receiving food that has higher aflatoxin contaminations. And so that is that's the summary of this work that we've done on how world food trade and aflatoxin regulations go hand in hand. Thank you for your time.